Hi, welcome to the flipped instructional session on Unit 102 in Math 08B, Patterns in Two-Way Tables. So today we're going to talk about creating a two-way table to represent data, create a relative frequency table for a two-way table, and finally compare two sets of relative frequency data and describe possible associations between the two sets. There are some new vocab words that we need to know moving into this lesson. The first is a categorical variable. And this is a variable that is separable into mutually exclusive groups. So for example, boys and girls, athletes and non-athletes. A two-way table is a table that is used to compare two of these categorical variables. So a table might be comparing boys versus girls or athletes versus non-athletes. And a relative frequency table is a table that describes the percent of occurrence of the values or intervals in a data set. So the frequency table deals with the percentages. Before we get started, let's do a quick review on converting fractions to decimals and then therefore a percent, which is something that you'll be doing on the tables. So if we have 4/10, you can either divide this out in a calculator 4/10, or you may already know that 4/10 is written as 0.40 as a decimal. And we convert a decimal to a percent. We take the decimal and move it over 2 places to the right. So that's 40%. So that's 4/10. For 4/5, again, you may already know what that percentage is, or you can put it into your calculator. And if you put it in your calculator, you will find that 4 divided by 5 is 0.8. So I'm going to write it as 0.80 just because I know we're also going to be converting this to a percent. So the decimal is 0.80. And when we convert this, we move this decimal over 2 times, and that is how we get the percentage of 80%. So let's take a look at finding the categorical variables. So this says 20 boys and girls were surveyed to find out whether they chose to study Spanish or French in school. So what are the two variables in the problem? So we need to pick 2 of these. The number of boys and girls, the gender of the person surveyed, the language chosen. So we know that we talked about boys and girls, and we talked about Spanish and French. So we know the language chosen is definitely one of the variables. The other variable is not the number of boys and girls, because we don't change the total number. It's 20 boys and girls, so it is not changing, but the gender of the person, that is one of the variables. Did you survey a boy or did you survey a girl? So the gender of the person surveyed and the language chosen. So let's take a look. Now we're going to complete the table below. So this is a two-way table. We have boys and girls, Spanish and French. It's okay if you put boys and girls up here and Spanish and French down here. But what we see is this box right here would be the number of boys who chose Spanish. Over here would be the number of boys who chose French. Next, we would have right here the number of girls who spoke Spanish, or chose Spanish rather. And then finally in this last one, we would have the number of girls who chose French. So we're just setting up this table so it's easy to read how many of each did the survey. So 20 boys and girls. Of those surveys, 6 boys chose Spanish. So boys, Spanish, so this is 6. 4 boys chose French, so boys, French. 3 girls chose Spanish. And finally, 7 girls chose French. So this is a two-way table that summarizes this data. And we could kind of do a double check. Sometimes they don't explicitly say 6 boys and 4 girls. They might have something that says like that you have to count it. So it might say yes or no, and you're counting the number of yes and no's, and then you're making the tally. But we can see that 6 plus 4 is 10. 3 plus 7 is 10. So 10 plus 10 is 20. So we can see for sure that we got all of them. So that's just a quick check and something that you'll want to do as you're making the tables when the data isn't spelled out as this. Okay, so the next thing they want us to do, so we have the same problem. 20 boys and girls, 6 chose Spanish, 4 chose French. Of the girls, 3 chose Spanish, 7 chose French. And it says complete the frequency table. So frequency table, the last one said two-way table. And this one's and to show the proportion of boys and girls who chose each language. Use decimal values. So before, let's just write it kind of down here in the same way we had before. We had 6, 4, 3, 7, and we said that there were 20 total. So to find the decimal, we're going to do 6 over 20, 3 over 20, 4 over 20, and then 7 over 20. So this is the frequency table. And it said to use decimals. So 6 divided by 20 is our first, and we get 0.3. So you can just put this in your calculator. 6 divided by 20, 0.3. So 3 divided by 20 is 0.15. 4 divided by 20 is 0.2. And finally, 7 divided by 20 is equal to 35. And if we added up these percentages, or excuse me, these decimals, we would get a total of 1. And if we did these in percents, we'd have, so these are the decimals, and that's all they asked us to do. But if we converted these to percents, we would find that would equal 100%. So that's another easy check to make sure your table is accurate. All right, so we have the table that we just made right here. Same thing, 20 boys and girls. Of those surveyed, 6 chose Spanish, 4 chose French. Of the girls, 3 chose Spanish, 7 chose French. What percent of those polled were girls who did not choose Spanish? So this is another way to ask a question when they ask who did not. So you have to make sure that you're reading carefully for the who did not. So it says what percent of those polled were girls. So we only want to look at the girl row. Girls who did not choose Spanish. So that's 0.35. And to convert the decimal to a percent, we move it over, and that's 35%. Thanks for watching. You can look for the Flip follow-up session in your Class Connect schedule, and you can attend that live session to do a little bit more practice and ask questions on this topic. You can also watch the recording. You can also attend a help-led session for extra support. Thanks.